First of all, I'd like to welcome everyone to this session. It's session KS, Infrastructure and Application Modernization on IBM Z with Red Hat OpenShift. Now, we will be recording this session and there will be a QR code later on for you to scan so that you can offer feedback because your feedback is important to us. Now, today we're joined by Marcel Mitran from Canada. His current role, he collaborates with research, with developers, with academia, and he's trying to drive innovation. Now, a lot of people try and drive innovation, but he can actually back this up as well with nearly 300 patents. So with that, Marcel, I'll hand over to you to tell us all about application modernization.
Thank you so much. All right, so as mentioned, my name is Marcel Mitran. I'm an IBM Distinguished Engineer. I'm the CTO for the Linux One servers and environment. So I have Linux on Z, and the broader Z ecosystem is very much part of my DNA. And as part of that, I'm also the CTO for Red Hat Synergy for IBM Z. So I work, hand in hand with the Red Hat team to bring their portfolio and integrate their portfolio with the broader Z platform. So Linux, but also ZOS and everything else on Z. And so today I would like to share with you a lot of the work we've been doing around OpenShift, specifically on Z. OpenShift has been available on the Z platform now since February 13th of last year. So it's been more than 18 months that we've had a fully supported OpenShift environment running natively on Z. And that's been a really, really important part of the IBM Z strategy around hybrid cloud. And hopefully, this will resonate and make sense. As we look at how clients are adopting hybrid cloud technology, what we're recognizing is, that there needs to be an abstraction layer that helps clients move between the different cloud platforms where they want to deploy workloads. And that's why OpenShift has been so important and strategically has underpinned the IBM hybrid cloud strategy, and largely why IBM acquired OpenShift and Red Hat initially. It's because what we have with OpenShift now is a cloud native platform that plays on any infrastructure layer that that makes sense, that you could think of, right? Be it in the hyperscalers, right? Be it AWS, Azure, Google, the IBM cloud. You can run Red Hat managed services in all of those clouds today. So you can have a Red Hat OpenShift experience and deploy your OpenShift enabled workloads in any of those hyperscalers. Similarly, you can run those workloads on your on-premise infrastructure, right? Most clients have a large investment in IBM Z and Linux One. And so they, for good reasons, they will want to deploy workloads on that existing infrastructure. And I'll talk about some of those reasons later on. And so the intent here is, as long as you're replatforming to OpenShift, you can take that workload to any of those pieces of infrastructure and never have to replatform them again, right? Replatforming is a very expensive and painful thing to do. So when you do it, you want to do it once, and you want to know that you're not, then locking yourselves into a specific outcome, a specific piece of infrastructure. You want to make sure that you have portability, the ability to do fit for purpose placement of the workload, right? When it makes sense to go here, you can put it there. And if business conditions change and the workload needs to move here, well, you can just lift and shift it as you need to and redeploy it where it makes most sense for your business at that point in time. And that's really what's underpinning the value proposition of why OpenShift, right? It's that abstraction layer that gives you the build once, deploy anywhere experience. Now, what we've done on top of that as part of our hybrid cloud strategy is we've taken the rich portfolio of enterprise software that IBM has built over the last 3 decades, and we've containerized all of that technology so that it can run on top of OpenShift almost like building blocks or like Lego blocks, right? The idea here is, OpenShift is kind of the Lego platform, and then each of these software components become Lego blocks that can sit on top of that platform and be quickly assembled and reassembled to meet the needs of the business, because they're all these nicely containerized assets now. And then of course our services teams know how to do this and support this. And we've been partnering with vendors like Temenos and Finacle, right, and Zafin and Fujitsu and Packbase and Vestigio and so on and so forth. We've to bring their solutions into this as well and make their solutions available as part of this set of Lego building blocks as well, right? So it's creating this ecosystem that really allows clients to now move very quickly to build, to meet the needs of the business, developing solutions, right? It's just that Lego block experience. And then to also be able to make intelligent decisions about where to put the workload and know that they can change their minds on a whim and move the workload around as necessary, right? So really giving them the end-to-end story there from a value proposition perspective. So so that only makes sense if OpenShift on Z is the same OpenShift as OpenShift on any other platform. And lo and behold, it is. It's the exact same OpenShift. We're porting the exact same code. We deploy it concurrently across Intel, across Power, and across Z. So, it's like the minute it comes out on Intel, it comes out on Z and P as well. That's because it's built from the same source and deployed in the same manner across all platforms. And just to kind of make the point about it being the same OpenShift, one of these images here is an OpenShift on Intel, and the other one is OpenShift on Z. And I challenge you to tell me which one is which. You can't tell the difference, right? They're identical. In fact, you'd have to figure out how to click two or three ways into the menu to figure out which one is which. And so it is the exact same OpenShift. It's the same experience, right? And that was always sort of critical to that underlying value proposition of creating a common abstraction platform, a cloud native platform that can play on any piece of infrastructure, including Z and P as a first-class citizen. We invite you to try it. The Linux One Community Cloud gives you a self-paced tutorial where you can stand up OpenShift and deploy a Liberty workload. Anybody can get free access to an environment and work through the tutorial at their own pace and experience OpenShift on Z for themselves. It is the exact same experience as in any other platform. So after we GA'd OpenShift on Z more than 18 months ago, I mean, the adoption has been phenomenal. It's just been amazing to see the momentum behind this worldwide. We have customers in production. We have about a dozen customers in production today with OpenShift worldwide, across industries, across geographies, and that's despite it only being available for 18 months. And so it's been a really, really good story. And the use cases are very interesting as well. And so what's underpinning, what's driving this interest and this momentum, right? What is it that clients are buying into and digging into here? So it comes down to a few things, right? So at the end of the day, the role that IBM Z plays and Linux One play, at the center of the enterprise as a system of record, right? A system that provides low latency, large volume data serving and transaction processing, that has the elasticity, the scalability, and the resilience and the availability that the enterprise needs for that core system of record. And of course, security and compliance is another core tenet that's been engineered into these systems over the last 6 decades that we've been engineering these systems in the context of the modern enterprise, right? All of those value propositions that are foundational to the value proposition of Z and the role that Z plays, really at the core of the IT landscape for the modern enterprise. Well, none of those value propositions go away or are less necessary because you've chosen to adopt the cloud native strategy as an organization. You still need the low latency, large volume data serving and transaction processing. That hasn't changed because you've decided to consume IT via a cloud native platform. You still need the security and compliance. that hasn't changed because you decided to start consuming your IT through cloud native, right? Cloud native is just a consumption model for how to consume IT and how to accelerate innovation as a result. But that consumption model is equally as necessary on that core system of record as it is on the digital channels that live around that system of record. Both require the innovation and the speed of innovation to meet the needs of the business. In fact, if you're only focusing on those digital channels from an innovation perspective, and you're kind of leaving the system of record out of the story, what you quickly find out, and many customers and clients and enterprises have figured this out, what you quickly find out is you're actually moving at the lowest common denominator. You're slowing down your ability to innovate on those digital channels because you're not including your core system of record in that innovation roadmap. And in fact, there's a rich amount of data and a rich amount of information that sits on those system of records that play a vital role in driving a digital transformation strategy and supporting the innovation roadmap of the enterprise. And if you're not leveraging it, you're leaving a lot on the table. And so that's really got a lot of customers, as customers sort of embrace cloud native initially in the digital channels, they kind of realize, wait, that's not good enough. We need to be able to drive the same strategy or extend the same strategy into the system of record. And so and that's why we're seeing such interest, right? OpenShift has really opened the aperture on that, and made it now possible to do that in a way that you couldn't before. And so we're seeing some really cool adoption patterns. The four that I like to talk about are enterprise hybrid cloud. And so this is all about leveraging the system as almost like a cloud in a box, right? The availability of the infrastructure, the scalability, the agility of the infrastructure to meet the needs of the business from an infrastructure perspective on demand is really what plays up there. Digital transformation and modernization for ZOS. A lot of clients who obviously are on a digital transformation strategy or a modernization strategy, and they're looking at how to extend their investment in ZOS with cloud native assets. There are some challenges in doing that when the cloud native platform isn't close to where the data is. OpenShift on Z addresses a lot of those concerns, and I've got some examples that I'll dig into in a minute here. Secure cloud native, as we look at emerging workloads that have a strong requirement around data privacy, data security, the ability to run those workloads on infrastructure that brings trusted infrastructure into play to support and protect those workloads is really, really important. And so we've seen some nice adoption patterns there. And then last but not least is just the more efficient infrastructure of Z and Linux One is a great place for you to go and consolidate and reduce the total cost of ownership of a workload, right? If you can run the same workload with the same SLAs with way less physical infrastructure, way less power, way less footprint, way less people, way less software, you can get tremendous savings and better business resilience out of that environment. And so we've definitely seen people take advantage of that, the economies of scale there from a Z and a Linux One perspective as well. All right, so jumping in a bit into some examples here. This is an example of the digital transformation and modernization pattern. So in this case, this is a large North American financial services company. They have, like most large financial services company, they have a significant investment in ZOS, both for transactional and for batch workloads. ZOS is essentially their system of record. And they also, as an enterprise, have a strategy around cloud native first. In other words, when you build new business logic, the expectation is it will be built as a cloud native asset. It'll be containerized, and in this customer's case, they had already standardized on OpenShift well before the availability of OpenShift on Z. And so this client was challenged, right? They had this existing investment in COBOL-based business logic, and they were told, you want to extend your COBOL business logic, it has to be using OpenShift. And OpenShift was only available on Intel at the time. And so they tried, right? They basically said, hey, we're going to write some new business logic in Java or in Golang. We're going to containerize it, deploy it on OpenShift on Intel, and our COBOL code will just call out to that business logic, over the network. Whenever we hit that little piece of business logic, we hit the business logic in COBOL that needs this new business logic, we'll just call out to the service on the Intel infrastructure, and let's see what happens. And so they tried that. And the fact that they now had to go over a network to get from the COBOL code to the new Java and Golang code on Intel infrastructure significantly slowed down the workload. Okay, it was a batch workload that they tried this with, and that batch workload was an order of magnitude slower out of the box. It took 10 times longer for the batch workload to complete as a result of this change. And of course, that's not tenable, right? You can't have a batch workload take 10 times longer. In many scenarios, batch workloads have to complete for the business to reopen. They have to complete within a fixed window, and so this was not a tenable solution. The experiment was deemed to have failed, and they did not have a path forward to extend the existing business logic with cloud native technology. When OpenShift became available running on ZVM, they were quick to jump on it, try it, and deploy it. They deployed it into their ZVM environment that was sitting on the same physical infrastructure as their ZOS environment. They just took the existing Java code as is, right? Deployed it as is in a container on top of OpenShift on ZVM, and they did the same experiment where the COBOL code called out to this Java code running on OpenShift now on ZVM, and lo and behold, they no longer had this large latency problem that they had when they went to the Intel infrastructure. They reduced the latency quite significantly. In fact, between 7 and 15x. The chart says 7, but it was up to 15x. And so as a result, they were now able to complete the workload, the batch workload, within the time frame or the window that it was required to complete in. And voila, they were off to the races. They had a strategy now around how they could modernize and extend using a cloud native strategy, this time sitting on Z. And it all comes down to the fact that they no longer had to deal with this latency of moving between Z and Intel, because everything sits on the same physical infrastructure. The latency becomes essentially a memory copy inside the fabric of the system. So you've got this ultra fast, ultra resilient network, right, which you can further accelerate with hypersockets and SMCD, and everything was great, right? So they had an operational environment that met the needs of the business as a result. What else did they get out of it? Well, they actually also got an agile development environment to modernize with. In this old world where you have this large latency, the only way to really overcome the large latency is to take large quantities of that, like large swaths of that COBOL code, and have to move it all in chunks, right? And that's a very risky, low time to value, high risk, low return on investment, way of doing things. It's a waterfall approach, or waterfall methodology, right? One that doesn't succeed very often. Most clients will fail when they try to take millions of lines of COBOL code and just translate it all in one shot into Java and move the data and it should just work. Well, it doesn't, right? So that's what they get with this co-located model now, is a methodology where they can be much more incremental in nature. Because they're not having to overcome the cost of the network, they can move small chunks of business logic over in a much more incremental and agile fashion. And so they're able to significantly reduce risk as they modernize, significantly improve return on investment and time to value, right? They can just be very, very incremental in nature. And that's back to much more of an agile methodology. Agile is great, right? Everybody understands agile is the better way of doing things. And developers love agile because it takes a lot of their concerns or risks off the table. So really great story, both from an operational perspective, but also from a developer experience perspective, for why OpenShift on Z, solved a really important problem for this client. We have another client in South America in the insurance industry space. They did something interesting. They had an existing workload running on traditional WebSphere on Intel. And it was using data that sat on DB2 on ZOS. When OpenShift on Z became available, they said, hey, let's just do the experiment of taking that WebSphere workload and moving it over to OpenShift running on ZVM, again, co-located with the ZOS, the DB2 ZOS environment. And they saw a massive improvement in throughput, 400+x improvement in throughput. And that just goes to show, that network can be crazy expensive and can cause crazy overhead. And I mean, 400x is extreme. Not most clients don't see that type of improvement, but it just gives you a sense of just how costly the network can be. And so there's a lot of value in co-locating the application layer with the data layer on ZOS. And OpenShift just allows you to do that now as and consume it as a cloud native environment. When we talk about cloud in a box, what we see is clients really loving the topology of a Linux One environment or an IBM Z environment, right? An IBM Z system is not one system. It's really an aggregate of 85 different systems that share underlying infrastructure. You can put 85 different hypervisors on a single IBM Z or Linux One system. Any combination of ZVM, KVM, or even metal-based servers. Each one of those hypervisors can run thousands of Linux guests. We've put over 2 million Docker containers on a single Linux One system. That gives you a sense of the scale of these systems. And so you have this really unique sort of topology with this environment where you can move, all these shared resources that sit underneath the LPARs or sit underneath the hypervisor. You can actually move them around, right? And in a very non-disruptive way. And so that means that you can do things like scale up, right? And databases love to scale up. So if you think about the DB2 in this picture on the left, what happens when the load on that database grows as your business grows? Well, the most natural way of growing that database is to just give it more resources, give it more compute, give it more I/O, give it more memory. Let the database grow in the very natural way by growing vertically or scaling up. In the same breath, you can scale out on this environment. You can add Linux guests to these hypervisors. You can add logical partitions dynamically and non-disruptively. And so as you add new application layers, or the load on your application layer grows and you need to add more instances of your application, you can do that in a non-disruptive way by just scaling out on the same infrastructure. And again, you can move the resources around as you need to. And again, you never have to re-IPL or reboot this system as you do this, which is really the promise of cloud, right? The ability to scale as your business scales. And so a lot of clients are seeing that and saying, you take that in combination with the ubiquitous and open standard consumption model like OpenShift and Kubernetes underneath OpenShift, and you actually have something that's very unique. You have essentially this wonderful cloud in a box experience. And so you're able to provide infrastructure on demand to meet the needs of a business and consume it in a very natural and holistic way. And so that's really what's behind the cloud in a box use case. And so we have a client and another financial service client in North America who are leveraging this technology to build out essentially a cloud in a box experience in their data center. In their case, their data centers are maxed out. They are challenged to find place to put Intel infrastructure in their data centers at this point in time. They have no more power to give. They have no more physical footprint to give, and they're looking for a better answer, right? How do we bring down our power footprint, and how do we, get to a more efficient use of the space in our data centers? And so they're leveraging Linux One to do that, both for containerized workloads using OpenShift and also for virtualized workloads. And they're running all of this on top of ZVM. And so the idea is they take all of these underutilized Intel servers that are creating this massive sprawl and run them on a scale-up system where you can share infrastructure, get to much more efficient use of that infrastructure, save on power, save on physical footprint, save on software licensing as well along the way, and it's a win-win in in all dimensions for them. And so a great example of how clients are leveraging OpenShift and Linux One for a data for a cloud in a box use case. When you think about the cost of that environment, right, more efficient does have a lot of benefits to it, and that translates into a cost savings. It's not just a power savings, right? And we've seen customers, reduce their power footprint by moving or consolidating workload off of Intel onto Linux One by up to 70–80%. If your enterprise is on a carbon neutral strategy, or has made a statement about how they're going to get to carbon neutrality, well, this is a great technology to help them get there sooner. It's a great easy button if you're looking for ways to bring down the carbon footprint and the power footprint of the enterprise. And I know this is obviously a topic that's front and center with what's going on these days, and the COP26 meeting that's happening right now in Europe. Now, not only can you save on power and physical footprint, but you can also save on software costs and total cost of your software by moving the workload onto Linux One. And so this is an example of a core banking system running on top of OpenShift. So it's microservice enabled. It's a Java-based workload. And so the idea here is, what we did is we took the workload and we deployed it onto Intel infrastructure. Our intent was to not just talk about production, but to actually bring in an HA perspective and a dev test perspective, right, to really capture the full life cycle of the workload. We held the workload to a certain SLA. We expect it to be a responsive workload, and ran it on Intel infrastructure, and we needed 176 cores to run it successfully on Intel. Now, on Linux One, we needed 17 to do the exact same amount of work. So to cover the HA, prod, dev test, right, all of that in 17 IFLs. So we reduced the number of cores required to run the workload by an order of magnitude. 10 times less cores means 10 times less software licensing. And if you look at what costs, the total cost of ownership of a workload, what we tend to forget is that software tends to cost a lot more than hardware. And so if you can make meaningful savings on the software part of the equation, you typically can make meaningful savings on the overall cost of the workload. And so when you take into account the fact that you needed 10 times less software licenses to run the same workload, you needed less power, less physical footprint, less people, the workload actually was 60% less expensive to run on OpenShift on Z, on Linux One, basically, than it was on Intel. Now, where did we get that 10x reduction in core count from? Well, it came from the fact that the workload out of the box was 4 times faster per core, right? We could get 4 times more transactions per core out of an IFL or a Linux on Z core or Linux One core than we could out of an Intel core. And that's got everything to do with how the cores are designed with 5.2 gigahertz thread speed, large caches, massive IO, accelerator technology for things like Java, where we can do pauseless garbage collection through hardware acceleration, right? All of that adds up to making the workload just 4 times faster per core. Now you add into that the fact that we're running this workload at much higher utilization, right? Back to that sort of topology around, the scale up and scale out, that diagonal scale topology. The fact that we can run the workload at much higher utilization consistently means that we can also bring down the core count, right? So on Intel, you'd be running at, at best 15–20% utilization. We're running at 80–90% utilization on Linux One, and so we're able to save a lot on and bring down the core count significantly as a result of that, in combination with the better throughput per core. So that's how we get to 10x reduction in core count and get the savings from the software licensing perspective as well. Another reason why customers are adopting OpenShift on Z is because they're running mission critical workloads, and those workloads need to be running on hardware that's designed to be up 24/7, 365, right? So Z is 7 nines, right? That's less than 3 seconds of downtime a year. That's the high availability rating of a Z system, and so when this is a bank in Asia Pacific, they are redoing or re-implementing their consumer banking portal. And they're building it out as a microservice-enabled solution. And as you think about the importance of a consumer portal for a consumer bank, well, it is mission critical, right? If your customers cannot get to their banking information because the portal's down, the bank is as good as not in business, basically, right? Out of business. And so they really, as they engineer this new portal, they recognize that it has to be hosted on the world's most resilient hardware, and so they're going to host it on IBM Z. And so, they recognize that the mission critical workload needs to run on a mission critical hardware, right? Back to sort of the value proposition of Z and why that doesn't change just because you're consuming the workload as a cloud native workload. You still need the resilience of the underlying infrastructure to support the business requirements of the workload. And so great, they made the choice to run it on OpenShift on Z. Blue Barricade is a vendor out of Scandinavia. They do a ton of awesome work around blockchain technology, and they recently announced, put out a press release stating that they had reached this amazing milestone of 1,400 transactions per second for a blockchain solution. And this is basically the IBM blockchain platform running on OpenShift on IBM Z and Linux 1, right? And so they're really leveraging the design and the engineering around the processor technology of Z, the security differentiation of the platform to host this solution, and get this, achieve this amazing milestone of 1,400 transactions per second. They're really leveraging a lot of the acceleration that we've put into the IBM Z processors around hashing, that then gets consumed and helps accelerate blockchain technology. And so really, really great story for the value proposition of blockchain technology running on OpenShift on IBM Z and leveraging the IBM Z differentiation around security and acceleration to reach this amazing milestone. All right, I will, those were all the why OpenShift on Z use cases, a good coverage of the various use cases, and hopefully that resonated with you guys, and you got a sense of why we're seeing so much excitement around this technology and why it makes sense for OpenShift to run on Z if you're trying to address power footprint problems, carbon footprint problems, if you're trying to deal with out of control Intel sprawl, if you're modernizing and need to keep your cloud native applications close to the data on ZOS, if you're looking at new workloads that are running blockchain technology or digital asset solutions, right, leveraging the security of the platform in combination with the OpenShift consumption model. Hopefully those are resonating and helping to sort of get some interesting ideas going about and to help you sort of understand the excitement here that we're seeing around the technology. Another really interesting part of this, our whole partnership with Red Hat has been, really engaging on the developer experience, specifically in the ZOS domain, right? And really meeting developers where they are as they, come out of school and embrace the platform and work on the platform. And so we've done a lot of work to help improve or meet the needs of a modern cloud native developer on the ZOS platform, and that's largely in partnership with Red Hat and leveraging a lot of the OpenShift development experience here to do so. If you think about why people are embracing hybrid cloud, and it's because they're really looking to accelerate outcomes, right? They're really looking to accelerate innovation and achieve business outcomes faster, right? IT is not there for the sake of IT. IT is there for the sake of making, helping the business succeed at disrupting others as opposed to being disrupted. And that only makes sense if you're delivering feature function to meet the needs of your market as effectively as possible and quickly as possible. And that comes down to making sure developers can do their jobs and deliver on feature function quickly and effectively. And so that's why everybody's so excited about cloud native. And Deb, who's a new ZOS application developer, should have a cloud native experience when she's developing for ZOS, just like developers on any other platform. And so we've done a lot of work around helping Deb. And so part of what we've done is we've actually enabled ZOS to be managed from OpenShift. And so this is really an infrastructure as code story. And so we have this technology called the ZOS Cloud Broker, which is essentially an add-on that sits on top of OpenShift and allows OpenShift to deploy and manage resources on ZOS. And so what that means is you can now have kicks as a service as part of your OpenShift catalog, right? A developer can come along and say, I need to deploy a kicks region, and this will automatically go off and talk to ZOSMF or deploy Ansible playbooks to stand up a kicks region for that developer. They don't need to engage with a sysproc. They don't need to go through weeks and weeks of iterations on I need this, I don't need that, and the challenges of that, sort of human interaction, which tends to be slow and error prone. This allows them to get to a repeatable automated environment. And so that repeated automated environment gives them then the ability to get what they need when they need it much more quickly. It also allows the system programmers to focus on more interesting work than just responding to individual sort of requests from different people about, oh, I need this, I need that, I need this, right? It allows them to focus on building repeatable processes and automation, which then make everything much more scalable and certainly keeps things a lot more interesting for everybody as well. And so the ZOS Cloud Broker is a way for ZOS to participate in the OpenShift experience from an automation and repeatability perspective. And what that means is not only can Deb go into the OpenShift catalog and say, I need one of those kicks regions, but she can also now write YAML, so automation that can do that automatically. So if she's building a solution that requires a kicks region, a DB2 schema, and a service that runs on Kubernetes, on Linux, on Z, she can write a single script that stands up, deploys the workload across the 3 environments, tests it, and tears it down. She can do that with a single script, and that's fully automated and fully repeatable, right? No need to insert human error, no need to slow things down. It's fully automated, fully repeatable, and that's really the promise of cloud, right? Is that repeatability and automation. So the ZOS Cloud Broker is part of a bigger story that we've been working on called IBM WASI Developer. And so what WASI Developer is it's really bringing a few things to bear in the context of cloud native development for ZOS. One, it's giving you a modern IDE, a modern integrated development environment. And so now we're talking about anything from Visual Code, Microsoft Visual Code, to Eclipse, to Red Hat Code Ready Workspace. You can run them all as part of WASI. So meet developers, where they're at, right? When they come out of school, they probably have one of these 3 development environments that are pretty standard and ubiquitous in the industry. They probably are comfortable with one. The truth is, and so they can pick the one that they're most comfortable with. And what they'll get is they'll get the rich language support and experience for COBOL, Rex, PL1 that they would on any other language, right? We've taught the IDEs how to understand those languages and represent them in a way that's, that the modern developer would expect to be met. All of this runs on top of OpenShift. It runs on x86, it's deployed as a container, and so it's all very repeatable, and so on and so forth. We also have WASI Sandbox, which allows the developer to go off and deploy an entire ZOS system on top of Intel infrastructure. And the idea is to give these developers an environment where they feel safe, ultimately. Where they can do things, and if they mess up, they don't hurt anybody else. They don't bring down the entire kick system. They don't bring down the sysplex, or hopefully. What they really do is they really only bring down their little sandbox. And so that, as a developer, especially if you're new to something, one of your biggest fears is, if I make a mistake, who else am I going to hurt? What else am I going to break, right? And so giving them an environment where they can make mistakes and it doesn't hurt anybody. They have it's a completely containerized environment, so they can tear it down and they can just bring it back up on a whim on their own, right? Gives them the freedom of action and the security that they need, the safety net that they need to feel empowered, right? And to do the testing they need so that they're comfortable with what they've done successfully. Then WASI Analyze allows you to look at the code changes you've made and understand the implications and the effects of your code changes on other pieces of code around you. Again, it's all about safety and giving developers the comfort that what they're doing is not going to have a detrimental effect. It's going to have the intended outcome and nothing else. All of this also ties into standard DevOps technology for continuous integration and continuous delivery. So it talks to GitOps, it talks to Zoe, it talks to Artifactory, and so on and so forth. And so you get truly a standard set of tools that everyone would be comfortable with. You get a nice, safe environment to do your development in, and an understanding of how your changes are going to affect others. I mean, this is really, helping developers, meeting developers where they want to be met, especially for, again, developers who are new to the platform and are new to the code, obviously are going to need some of that comfort to feel like they're, to help them succeed. So just some examples of the syntax highlighting here. Another sort of really great example of of how WASI Sandbox works, right? So you can deploy your sandbox on any Intel infrastructure. It doesn't have to be Intel infrastructure on premise. It could be Intel infrastructure out in AWS or in IBM Cloud, for that matter, or Google Cloud or Azure, right? And so that just means that you're also empowered to find the infrastructure you need when you need to find it. And it doesn't become a big deal, right? Where do I find an Intel box to deploy this on and test this on? You have freedom to do it wherever you choose to go and whatever makes most sense for you at that point in time. Right. And so this is what we want Dev to experience. This is, a very standard experience for a developer, right? They get notified that they need to work on a feature or a defect. They create a workspace to do that in their IDE. They then make a copy of the environment that they're working on. They don't work on the live environment, they make a copy of it. They figure out what changes they need to make. They make those changes, they build, they test, they debug, they build, they test, they debug until they get to a point where they're comfortable with what they've done. They then check in the code to the repository. The CI system, the continuous integration system, then grabs that code and starts to build it out and deploy it, basically. And Deb gets insights into what she's done, and the workload gets deployed into production, right, after it's gone through the appropriate CI/CD pipeline. This is what any developer would expect in a modern development environment today. And this is what an enterprise expects when they're looking for, the ability to build and deploy feature function at the speed of business, right? The ability to deploy hundreds of times, thousands of times a year into production and with confidence is really, really important to enable that feature function to be built and deployed effectively. And there's no reason you can't do this on z/OS just like you can do it on any other environment. The tools are there, they exist today and are available. Okay, so just final chart, taking a step back. When you look at our strategy, right, our strategy is OpenShift, OpenShift everywhere, build once, deploy anywhere, including z/OS with the z/OS Cloud Broker and Ansible operators, right, the ability to include z/OS in that picture. Kubernetes on ZVM, on KVM, and on all other infrastructure to deploy containers. And really to give clients the ability to have agile delivery solution for a repeatable environment. Everything as code, and to consume infrastructure as it should be consumed. And then it becomes a question of where does it make sense for the workload to run, right? The ability to do fit for purpose placement, put the workload where it makes most sense based on the existing business conditions, and then to change your mind, right? It's really important that you have the ability to shift and make a change as necessary. And that's the whole point around OpenShift, right? Is to give you that ubiquitous, common, abstracted platform that can go wherever your workload needs to go and gives you the ability to move it around as necessary. And of course, you know, Z and Linux One and ZOS are central to that, right? As the core environment, the core mission critical systems, they have to play they have to be first class citizens in that strategy for that strategy to succeed. And that's why OpenShift on Z is so important and plays such a critical role in the modern enterprise. All right, thank you. That's all I had today. I don't know if there are any questions.
There are none posted in the chat. We'll give people another opportunity just to raise their hand or put something in the chat to say that they'd like to ask a question. To truly shift work anywhere, don't I need a binary for each platform I want to work with?
You do, and so I mean, the elegant thing about having CI/CD pipelines is it's trivial. It's very trivial to add, you know, to create two binaries instead of one, right? When your CI builds and deploys a binary, it can equally deploy an S390X binary as it can an x86 binary. And we have clients who do this as a matter of fact today, and it's you know, it's nothing. It's easy. Right, it's just one extra step in that CI pipeline to say, hey, I also need an S390X binary to do it, and so that's a non-issue for anybody who's adopted this technology.
What about the vendor middleware versus build your own stuff?
So I mean, vendor middleware, I mean, a lot of it's there, not all of it's there. So it's a question of what you need. I mean, we've been very focused on vendors that we think have a value proposition on the Z platform. So Temenos is a great example. Fiducia Enterprise Postgres is another one. From a Cloud Pak perspective, you know, IBM's own middleware platform. We've got a great story around the Cloud Paks. It wasn't a great story initially when the Cloud Paks became available, but we filled a lot of those gaps over the last year. We've been very focused on addressing that. So I mean, it's not perfect, but it's definitely looking really good. We definitely have a great story around the middleware space, and build your own. I mean, if it's Java or it's Node or it's Python or Golang, it just works. I mean, that's the even easier stuff, because all of those languages are fully supported today as you know, S390X enabled languages.
That's great, thank you, Marcel. And in fact, that was echoed. Thank you. Thanks for taking the time to take us through this today. We don't have any more questions at the moment, and hopefully the weather is okay in Canada and you can get back to work with whatever time difference it really is out there.
Well, thank you, Nick. I really appreciate you having me, and really enjoyed it. So thank you so much.
Well, perhaps see you face to face at GSE next year.
Yeah, I would love to.
Okay, with that, I'll close this session. We reopen again 9 o'clock tomorrow morning with the stream sessions. So see you then.
All right.
Bye.
Thanks.